Hello, in this video I'm going to go through the examen VWO 2022 Tijdvak 2, the first period. Total time is 3 hours. As usual, you can make use of these so-called goniometrie formula, including like the sign of a double angle. So you don't need to remember them, but you need to know they're there, the first page. The first question is about a buigraaklijn, which basically is a point of inflection. There's a function f given here by this expression, and they state that the afgeleide, which is derivative, is equal to this expression, and we need to prove this, bewijs dit. So for this we can use the kettingregel, so-called kettingregel, chain rule. And of course what you need to know are the derivatives of common functions, including the function x to the power n. Just continue then. So for this we make use of the chain rule and known derivatives that you need to know, including the derivative of a function x to the power n. So we have 2x minus 1 to the power 3, so this the derivative becomes 3 times this to the power 2, and the derivative of this becomes a 2 in front times 2x minus 1, and then according to the kettingregel we need to multiply by the derivative of 2x minus 1, which is 2, so you get these two and here as well. So just work this out, combine the like terms, and then you easily get the answer. In question 2 they state that a line K has a tangential point with F in the inflection point. So from this I guess you can already assume that it has an inflection point. Now we know that at an inflection point, buigpunt in Dutch, we need to have the double derivative to be 0. It's not a sufficient condition, but it's definitely necessary. So let's calculate the double derivative, which means taking the derivative of the derivative, and again you get you need to take the derivative of x squared here and of x here, so you get 2 times 48 here, minus 24 times 1, and we want to set that equal to 0 and solve for that, and we find x is equal to 1/4, and as you can see this is a line that's going up, and you can then easily see that to the left and right this will change sign. It's actually crossing the x-axis, so indeed it's a inflection point. So whatever this line K is, it has the slope 1/4. No, sorry, it's at x is equal to 1/4, and to find the slope we need to evaluate the derivative at 1/4, so that means substituting 1/4 in the expression of the derivative here. So you get this expression here, which you just have to calculate, and you get 10. Sorry, well, you get minus 3. There's a lot of lag in these bad programs. Still have to find actually a real good program. Is minus 3. That means that the line k they're asking for has this form. Y is minus 3x plus some constant b, which you have to find out. Well, how do we know? Well, we know that 1/4 and f of 1/4 has to be on k. That's the so-called tangential point, raakpunt, of het buigpunt of the function. So, substituting that, we find that b has to be equal to the function at 1/4 plus 3/4. And that's again some calculation. You could even do it on your graphic calculator and then figure out what this fraction should be. And what you find is 5/4. So we know what b is, and now we know the total expression of the line they were asking for. Okay, next question. Diagonaal van een vierkant. It means diagonal on a square. So they define a square with side 2. So all 4 sides because it's a square. And there's a point M in the middle. So we know the coordinates of this. This is 1, 0. And there's we have point D here, which has to be x is 0 and y is 2. And you can construct a line that is perpendicular point P, for which the angle between line DP and MP is perpendicular, 90 degrees. And this point P is not equal to point A or C, so it's in between. And they have to be perpendicular to each other. So for this, possibly some geometry way is possible. But given that all the points except point P are known, we can just try to define the line MP and the line DP, and then making use that these slopes are related since they're perpendicular, and then see how it goes. So we can say the line MP is this kind of standard form with this point on the line. So if we substitute this, x is equal to 1, y equal to 0, the constant b of this line has to be minus a. So line MP is given by ax minus a, with a yet unknown. And since line DP is perpendicular to line MP, we know the slope is minus 1/a, meaning if you multiply it with the slope of MP, a times minus 1/a is equal to minus 1, which is the condition for slopes or for lines to be perpendicular. So, do the same trick. We demand that 0, 2, point D is on the line, and obviously this is actually the intercept of the line, so, and that's at y is 2, so this constant has to be 2. So this is the expression of line dp, minus 1 over ax plus 2. And then this line AC is simply y is equal to x. So let's determine point P by intersecting it with y is x. And that has to be the same for both lines as given. Okay, so let's first intersect MP. So since y equals to x, you simply get this equation. X is a times x minus a, and you can isolate x and find that it's a over a minus 1. In the same way, if we solve x equals the expression of the line dp, you can again do some math here, basically using your what you call algebraic math skills. You get x equals 2 over 1 plus 1 over a, multiply the numerator, denominator by a, then you get 2a over a plus 1. So we found that the axis x in one case is here, in one case is this one, but they have to be the same. They have to intersect at a single point. That's given. So we have to set these two expressions equal. So that's this equation here, equality, and then we just again do some algebraic work. Basically, you do the, I think it's called cross product or something. You basically multiply both sides by a plus 1 and by a minus 1. So you get a squared plus a is 2a squared minus a, and this combine the like terms. Then you get a squared minus 3a equals to 0. Then you factor out a, which is a common factor here, so you get a times a minus 3 equals to 0. And a equals to 0, let's see, a equals to 0 means that basically line MP is a horizontal line, put a equals to 0, and that would mean that line would be similar to AB, so that wouldn't cross the diagonal actually in a point that is not A or C. So we can rule out A equals 0. Actually the same for line DP. Well, you have 1 over 0, but it actually would mean a vertical line, and the same, it wouldn't cross the diagonal inside the diagonal here. So we just work with the solution A equals to 3, and now we know point P, right? Because it's the x-coordinate of P is actually the same as the y-coordinate, so you get with the x-coordinate given here, which is, if A equals to 3, the same as here. So just you can take either one. In both cases you should get 3 over 2 for point P for the x-coordinate as well as the y-coordinate, of course. And then, since A is the origin, we can just use Pythagoras to calculate the length of AP. So 2 times the square of each component. If you work it out, you get 3 over 2 times the square root of 2. All right. So we have a function defined from 0 to 2 pi, given by 1 over 2 sine x. And they want to calculate the bereik, which is the range. And you can see that it's all, from the graph you can see it's all real numbers, with the exception of this area between the minimum and the maximum, so the local minimum, local maximum, let's say. So the approach will be just find these extremes here, and then we found the range. So we can use the chain rule again to calculate the derivative. Write it as in the form of sine to the power minus 1 of x, and so the function 1 over x has the derivative 1 over x squared, or x to the power minus 2, so it becomes sine to the power minus 2. And then you still have to multiply times the derivative of the sine, which is the cosine of x. So you get cosine of x divided by 2 sine of x. And we want to set that to 0. And that happens when cosine of x is equal to 0. In which case actually the sine of x cannot be 0. So we won't run into trouble there. When is the cosine x 0 in this domain? Well, half pi and 3 pi over 2. In general, you probably can just write it out first as this, and then so half pi plus n times pi, and just substitute which values of n, which integers n, bring you in this range. And in this case, that's n equal to 0 and n equal to 1. Okay, so now we need to find the y values of these extremes. So just plug in these numbers here. The sine of 1/2 pi is 1/2 square root of 2. So that's something you have to remember to do these exams. And in a very likely scenario that will come up. So you need to know the signs of the standard angle, 30 degrees, 45 degrees, 60 degrees, etc. Okay, then, and for 3 over 2 pi, again, you need to know the sines and cosines of these standard angles all along the unit circle. And so in this case you get 1/2 for x equals 3 pi over 2, you get minus 1/2. So that will mean the range is from minus infinity to minus 1/2, and from 1/2 to positive infinity. Okay, now they give a function GA of x, the same domain, and they're asking for which value of a does this function GA not have any intersection with function f. Well, the best approach here is just calculate the intersections where these functions cross and just demand that there are none. So just set the functions equal. So 1 over 2 sine x is equal a cosine x. Multiply by sine x both sides. And here again know your rules for trigonometry. This is actually one that was listed in the equations above, but best still to remember them and know how to apply them. So you use that 2 sine x cosine x is equal to the sine of 2x. So you get a times sine 2x equal to 1. So sine 2x is 1 over a. So if x satisfies this equation, then there are intersections. But we also know that a sine function is always in this range. So in other words, this can never have solutions if a is between minus 1 and 1, because then this will be greater than 1. But this doesn't necessarily mean it will have solutions if a is outside of this. So we just check it. If you like draw the sine of 2x between 0 and 2 pi, because there's 2 here, you get kind of 2 positive peaks and 2 negative peaks. And you can see actually for every a in this range from -1 to 1, it always has at least 2 solutions. Actually 2 solutions when a is 1 or -1, but in between it will even cross 4 times. So in other words, in this range there are certainly no common points, no intersections between these functions. All right, this is a long question. I noticed that recently these exams are like that. My time, long time ago, I just remember my Wiskunde A was called exam was maybe 2 pages at most. And in particular, if your Dutch is not that good, this might all be very confusing, but in the end, still try to get back to the math of it. And you can kind of see here there's a certain formula with a certain variable n, and as principle you could do it even without understanding all this, and you can read this at your leisure when you're home or something. So they give some expression for t, for something that is t and aantal tests, so number of tests, and n is the what is n? Number of samples in the test. Well, let's see what they're asking. They say that this say function t of n has a lowest point, a lowest extreme, which kind of can be seen here. So it's kind of slowly going up here. And now they ask use the derivative of t, which gives you a slope, and reason whether or not this kind of lowest extreme somewhere here is to the left or the right of n equals to 4. Okay, well, let's find the derivative. And again, the skills you need here are derivatives of some standard functions, 1 over n, and like a to the power n. You don't see that so often. It's actually a very simple expression. You just need to multiply the thing itself with the log of this a here, this base. So this is what you get, and then calculate it at x or n equals to 4, and this you can use the your graphic calculator. Then you find 28.89, but that's a positive number, meaning the slope is positive, it is increasing. In other words, since it's increasing, it means that the lowest point must have been to the left of n equals to 4. All right. Oh, again, a long story. I think they want to optimize or minimize the number of tests you need to do to get results in a certain lab. But they say the equation, if the given equation, if n is number of samples, monsters, and p is kind of a fraction of samples that are contaminated by this disease that is being tested. Again, it's not really necessary to understand all that. Just look at this equation, and what they are asking they're looking at a certain value for n for which Tn is t of n plus 1. And again, t is given here. And they say if t equals Tn plus 1, then we also have the expression here. So just try, start with this and try to see if you can come out with this expression here. So substitute n and n plus 1 in t. So Tn is given here, you can just directly copy that, but for the right hand side you have to take n plus 1 instead of n. And then you can see that the first of all you can drop n, and also the first term, you can, the n times 1, or basically the 1 term here, will also drop on both sides. And you can bring 1 over 1 plus n to the left. Well, you can bring the whole thing to the left here. And then you get 1 over n minus 1 over n plus 1 minus 1 minus p to the power n plus 1 minus p to the power n plus 1. This you can calculate by putting it under a common denominator. And you can also see, obviously, this is something to the power n, and this is something to the power n plus 1. So they have a common factor. That your power n term is a common factor, basically. This is just multiplied by 1 minus p one more time. So you can factor it, you can just simply write it as 1 minus p to the power n times minus 1 from this term plus 1 minus p. This 1 minus p here. And then you can see it becomes already more easy. The ones drop here. I was careful for the minus sign. And so you get 1 over n times n plus 1 minus 1 minus p to the power n times this p equals to 0. And then you can bring this to the right hand side and multiply both sides by n times n plus 1. And you get 1, which is exactly as given here. So basically here it's just using algebraic skills. This question, wow. So they say that they don't want to do more tests than 750. And if that's a constraint, they're asking of how many samples can you actually determine if they're contaminated or not. And there's some table here that you can use. Again, this might be a little tricky if you don't understand the whole long story here. But the fraction of samples that are contaminated is 0.025. And then we first determine n from this table. And so that's, you have to get it from here. The 0.025 is between this and this, so we take n equals to 7 and demand that the t, capital T, is less or equal to 750. So that means just substituting what we have for t here, demand that this is smaller or equal to 750, but with n equal to 7 and p is 0.025. That means that n has to be smaller than this fraction, which you just have to plug in the graphic calculator, and then you get this. So of course n has to be a whole number, but this wouldn't be satisfied if you pick 2457. So basically the answer is n is 2456. Okay, well, let's go back to math. And basic calculus. So we have a function f given by that expression. It's intersecting with the y-axis in 0, 4. It gives a rectangle here. And basically you can see this function f is of cutting the rectangle in 2 parts. And they ask for which q, so which size of rectangle. These 2 areas within the rectangle, but cut by f, are equal. So what we have to do is calculate the area under f, bounded by these by the y-axis, and line y is q. And then that area has to be half of the area of the rectangle with size q, which is and that is 1/2 times the size is 4 times q, so it's 2q. So the integral here has to be equal to q. And note that the q also enters the left-hand side here. Now another skill set here comes up, is primitives. So this is a kind of, if you look at standard function, more of the form x to some power. So x to some, say, power a. And we need to know how to find primitives of this, and we need to know how to find derivatives of this. So for primitives, you just go in the opposite direction, of course. So it will be something like x to the power, there's a big lag here, so I cannot really write. A plus 1, but then say if you want to, you always have to double check if you have a primitive to calculate the derivative and find out that you're back at the same function. If you calculate the derivative of this, you will get a plus 1 times x to the power a, which is not exactly what we have here, x to the power a. So we would just compensate by that by putting 1 over a plus 1 here. Okay. Sorry about the lag. So, yes, and in this case, a is minus 1/2. And you can also see it's actually not x, but x plus 1. So think about the chain rule in the reverse way. So this is x plus 1 to the power minus 1/2. And in a similar way, we just try this first. It should be 2 times x plus 1 to the power 1/2. Right? If I take the derivative, I get minus 1/2 here, and 1/2 here, which the 2 compensates. And then you see that this x plus 1 actually has no effect. If I apply the chain rule, I get the derivative of x, which is 1. So this simply is the derivative. Again, test this. If there would be a 2x here, then you would have another factor 2 here for which you have to compensate. If you have some x to some power under the square root sign, then it becomes more complicated. Because then the chain rule will give some x here, and you're not in the form that you originally had. Okay, so now we found the primitive, and we take it between q and 0. Let's see. Yeah, so don't forget about the factor 4 here. So you get 4 times 2, which is 8. So you get 8 times the square root of q plus 1 minus 8 times the square root of 1. And now we solve this to be equal to 2q. And here you have a term with a square root, q with a square root, and here this is the linear q. And just isolate the square root first and then take the square. And if you would take the square now, you won't get rid of your square root, and actually thinks that's probably not much use. So bring the 8 to the right, and also divide both sides by 2. You get this, and now you can take the square on both sides and combine like terms, bring everything to one side, factorize, and you get this equation, which has solutions q equal to 0, which we rule out because it's said that q is larger than 0. That means q is 8 is the solution, and that's actually the final answer then. Okay, so they give another function g, and this kind of a common questions. You have to calculate a area that's enclosed by these two functions in a certain area, and the x's are from the intersection of the two functions to x is equal to 4. Okay, that's not too difficult. But we first need to determine the lower limit, or the lower bound of the integral, namely a, and we do this by setting these functions equal, of course. Oh, sorry, I didn't mention that g is actually the inverse function of f. So, well, just first calculate the inverse then. Probably you can also use another property because a function and inverse are kind of symmetric in a line y is x, so their intersection will always be on this line. I'm not sure, maybe that could lead to another solution, but let's just calculate the inverse, and you do that by flipping y and x here and isolate y. So x is equal to 4 over the square root of y plus 1. Rewrite it a little bit. And again, on one side just has a square root, so you can take the square. And then you get y equals to 16 over x squared minus 1. So to find for which x they intersect, you get this equation. Okay, one thing I should have mentioned here, they don't say you need to give an exact answer. As a matter of fact, you can approximate it to 1 decimal. And it's always the case that usually it means that there are certain expressions you better just use the graphic calculator. So wherever it's more, saves you time, and the expressions are not too tough to put in, just use the calculator to find what your x is. This could be a little bit tricky even to do it analytically. So doing that, you get, and just keep a couple of decimals for now, with 2.26. And then the same, since you're basically using the calculator, just do the whole thing, the whole expression by using the calculator. And if you do that, you find 1 decimal 2.1. So this illustrates first things you need to prepare and need to know. This about inverses, how to calculate the inverse of a function, how to intersect functions, how to numerically calculate integrals. That you have to know with your graphic calculator. Okay, next question. Circles. So for t in this range, a point P is moving along a circle with center 0, 0, and this has the equation of motions given here, which makes sense. This is a circle with center 0 or origin and the radius 2. So that is our P, and then we have a Q in the same interval along the circle CQ with this equation of motion. And for these, I think what you have to know is, if you see these, how they look like. And this is a circle with radius 2 and center 0, 0. And this would be a circle with radius 1, like the amplitude in front of the cosine, with center 2, 0. Now, this angle BOQ is dependent on t. That makes sense. And in this figure they show a situation where OP and OQ are perpendicular, and they ask for which t are they perpendicular. Well, I guess it's just brute force. calculating OP and OQ, the expressions for the line, or just a vector, and just demand that these vectors are perpendicular. So, yeah, if you write down the coordinates of P as function of time, you could just for OP you get 2 cosine T, 2 sine T, and for OQ, again substituting what you have here, 2 plus cosine T for X and sine T for Y. And to be perpendicular, you just demand their in product to be 0. That's another kind of part of the factors related skill sets needed for this exam. You need to be able to calculate the in product of two factors and how this relates to the angle between the factors. Okay, it's not too difficult. You need to calculate the product of the x plus the product of the y's of the factor. So you get 2 cosine t times 2 plus cosine t plus 2 sine t times sine t is equal to 0. That is nice because you get a cosine squared plus sine squared, which is 1. So you get 4 cosine t plus 2 equals 0, or cosine t is minus 1/2. And in this domain here, so I can use your standard knowledge of the standard angles. And you'll find, see, this is the second time it occurs already in this exam, so better learn that. You get t equals 2 over 3 pi plus 2 n pi, and again check for which n. This is t is in this interval here, and that is only for n is equal to 1. And then you find t is 2/3 pi, which should be the answer here. You might want to, it probably makes sense. So cosine t is minus 1/2. Okay. Now you can have a point M right in the middle of P and Q. At t is 0, of course, point P will be here and point Q will be here, and they both start moving. And of course M kind of moves up with them, and they give the situation for like 3 time values. And then for point 7, it will be it will be just going outside the circle. So it's point M is exactly lying on the circle at this time. Then it will be outside both circles, and at a certain time it will be on exactly on this circle P. So for certain percentage of the time that it will move around, it will be in it will be outside of both circles. And then you need to calculate for what percentage of the time. So for M, so M is kind of moving around here. But what you can see is from the first part of its path will be symmetric to the second part. So we can just look at the upper part here. So from t from 0 to pi. Now if t is pi, then p is here and q is here. So you get, so m is somewhere here. So let me try to, if, so this is for t is pi, and then p will be here, q will be here, so m will be here. So m is, so in the beginning m is here, so actually probably m is a circle. So in any case, we just need to look at time from 0 to pi, because from pi to 2 pi it's just coming back. So the percentage of time where it's outside these two circles is the same. Actually I skipped a question. I'm sorry. I should do 12 first. Okay, sorry, let's go back. There's a line between P and Q, obviously. So there will be something like this. And they say it will intersect the x-axis in a point A. And then this, they say that no matter what t is, this line will always cross in the same point A. That's interesting. Okay, well, how do we show that? That's what they're asking. Well, calculate the intersection. Just define, write an expression for this line and intersect with the x-axis, and then just show that that doesn't depend on t. So when you need to set up lines, in the previous exercise I just used kind of the general form, kind of the slope, called the slope-intercept form of a line, which almost always works. You can also use actually sometimes you can use a vector form of a line, which is more of expression of one point on the line plus some lambda again, the lag is killing me here. But let's just use the slope-intercept form. And well, what's the slope? Is easily gotten from these 2 points Q. So you just take Qy minus Py, which is your delta y, divided by Qx minus Qy, which is the that's a mistake here. That should be an x. I don't know why these writing pads are so lousy. So Qx is that, if you can decipher it. So now substitute Qy as function of time. It's sine t. And then you subtract y of p, which is 2 sine t. And you do the same for the x as 2 plus cosine t minus 2 cosine t. And this is just minus sine t. And you can also subtract the cosines here. So you get minus sine t divided by 2 minus cosine t, which is our slope A. Now we want either P or Q to be on the line. I don't know, it shouldn't matter if you take point P or Q. I took point P here. The coordinates of the y coordinate of point P is 2 sine t. This has to be equal to our A here times the x coordinate of P, which is 2 cosine t, and plus B, the B here from the line. Then bring this to the to bring this to the left and then flip sides. You get this expression for B, which is a little messy. You can actually write this as a sine of 2t, but let's see if that is really going to be helpful. Okay, so we have found our line P here, PQ here, and we want to find A, so we intersect it with the x-axis. In other words, we set ax plus b equal to 0. And A is given here, B is given here. So you get this messy equation right here, but some glimmer of hope. We can actually factorize sine t is a common factor. So we pull that out, and you get a kind of a product of two things is 0. That means either of these is 0. So either sine t of 0 or this expression here is 0. Well, let's look at sine t is 0 later, and just demand that this part in parentheses 0. So you get this equation. You can bring the terms without x to the right. I mean, the form is really simple. It's something like ax plus b is 0, right? It's just that each of these constants is a little messy. So what you do is, here we multiply both sides by kind of the inverse here, right? You want to isolate x. So here you get just 1x, and here you get 2, so you multiply by this, you get this minus times this minus is plus 2, so you get 2 times 2 minus cosine t. And the nice thing here is this 2 minus cosine t drops, so you get just a plus 2 times cosine of t. And now we say that this has to be equal to 4. I'm sorry, not. No, you just can evaluate this. You get 2 times 2 is 4, minus 2 cosine t, plus 2 cosine t, so they drop, and you get 4. So it means that it's independent of t. What's this? Surprising. Now the other solution would be the sine of t equal to 0. So if somehow this would be a situation that you don't intersect A, then actually it is dependent on t. So let's look at it. Well, sine t of 0, let's go back to our line PQ. Actually, that means t is 0 or t is pi. I think I just already showed that in that case, PQ is just the x-axis. But just look at the expression ax plus b is 0. Sine t is 0 means your a is 0, and it just means, and the b is 0 as well, so it's the x-axis. So PQ in that case is the line y equals to 0, which also contains a. So for all t possible t's, you found that this line will go through a. Okay, so go back to 13. I think I just already argued that you just need to consider from 0 to pi because of the symmetry. And, well, maybe there's some other ways, but what we can do is just give the expression for m and then see when it's not on inside one of the circles. And as a matter of fact, we already know at 0.723 it just moves out the circle Q, CQ, and we just need to calculate then, well, when does it start touching on circle P. And so that time interval then will be almost the answer. So let's set up a expression for m, a vector m. Well, it is defined as the point being in between q and p. So it's just half q plus p. And just substitute our equations of motion. And this will be the results: 3 over 2 times cosine t plus 1, and also 3 over 2 times sine of t. And I think, yeah, so this is actually a circle of radius 3 over 2, and the center point 1, 0, So you might actually as well try to calculate the intersection of this circle with the circle CP, but the result should be the same. So it leaves the circle at this time here. Yeah, so we actually we don't need to calculate, they already give it, so we don't need to calculate it, which is good. But we still need to calculate when it enters the circle P. Well, how do we know that? It happens as soon as the distance between M and the origin, which is the center of the CP, is 2, which is the radius of that circle. So squaring on both sides, and so the distance from M to the origin is just the length of this vector. So we this is the x squared plus the y component square of this vector. So just write that out, has to be equal to 4. Okay, get rid of the brackets here, and you get something cosine squared t plus sine squared t, which is equal to 1. So you just get 3 cosine t plus 1 plus 9 over 4, where this is the sum of these squares, which is equal to 1, and this has to be equal to 4. Bring these to the right side, then you get 3 cosine t is 3 over 4. Or, in other words, cosine of t is 1 over 4, and that is not a kind of standard cosine or sine. So just put it in your calculator with a couple of decimals, and you get 13181 in, again from 0 to pi. So then we know the time interval it spends here, and we want to know it as a percentage, so we divide it by the total time spent here, for like half a period, which is at times 100%, get the percentage, and then you get 19%. Again, it also spent time outside right here, but in that case you need to, so you could kind of multiply this by 2, but the total time will also be twice as long, so it won't change the result. Okay. Alright, function f is given by this expression here. It has a knikpunt. Actually, I don't know the name of that in English. It is a point where the derivative is discontinuous, so it, as you can see, it moves, it's actually from negative to positive, although it is continuous. The function itself is continuous, but the derivative is not. And then there's a line k, which is a asymptote, and they're asking to write down the equation for k. Well, these things you calculate by looking at the behavior. In this case, when x goes to minus infinity, or becomes like arbitrary negative large. So one thing you can use is, it's always tricky with this absolute value here, is that for sure x minus, the absolute value of x minus 1 is just minus x minus 1. And so fx in that limit, or if x is sufficiently negative large, you get this expression for the function. And you can actually write this under one denominator if you want, but it's not really necessary. You want, if you want to study the behavior, you can just look at this and divide both the numerator and denominator by x. Then you get 1 minus 5 over x divided by 2 minus 5 over x. So these two expressions are equal. And then take x, assume that you have ignored these, so that you get minus x plus 1 plus 1/2, which is minus x plus 3 over 2. All right. Some part of the graph is beneath the x-axis, as you can see. So that's actually from here, well, to here where you have this vertical asymptote. So determine actually what this interval is, where it's below. That's the question. Well, we already know that this knickpunt is exactly when x equal to 1. So we already know from the graph that the area where this happens will be in the area where x is larger than 1. So we can assume x is greater or equal than 1, which means that this absolute value just becomes x minus 1. So to find this intersection, we just said x minus 1 plus x minus 5 divided by 2x minus 5 is 0. Then we put it under one denominator. 2x minus 5 is 0. And we set the denominator as to be 0. And assuming that 2x minus 5 is not 0, which we have to check. So you get 2x, so working this out, combining like terms, you get 2x squared minus 6 is 0, 2x times x minus 3 is 0, or means x is either 0 or x equal to 3. But we should ignore this x equal to 0 because it is inconsistent with our assumption. And that is actually a situation if f of x wouldn't have this absolute value sign, then it apparently would cross in the x-axis at 0. Actually not sure. Yeah. substitute 0, yeah. If there's no absolute value signs here, you get -1, and if x is 0, this becomes +1, so then this function would have been 0. Doesn't matter. So what is this? We find x is equal to 3 as this point here. And the vertical asymptote, well, that's of course pretty easy to find. It's 2x minus 5 equals to 0, which means x is 5/2. So the interval for which f is below the x-axis is from 5/2 to 3, and not including these bounds here, because it's exactly 0 at 3, of course, and it's not defined at 5/2. All right. Last question. We have a function x times e to the power x, and p and q are on this graph. The x coordinate of p is the lowercase p, and the x coordinate of q is lowercase 2p. So p is given here then, right? And q is given here. And for a certain value of p, this line has a slope of 6. So well, what is the slope of the line going through p and q? Again, it's something like the delta y divided by delta x. And the y of q is 2p e to the power 2p. The y of p is p times e to the power p. And the delta x is just 2p minus p, which is p, right? So this is p. We can eliminate p. We need to worry a little bit about p is 0, but well, not really. If p is 0, then these points are the same, both the origin. So I think you cannot talk about the slope of a line going through the origin. They don't specifically say that p is not equal to q, but I think that's the reasonable assumption here. Okay, so this has to be equal to 6, so we get e to the power p, so I did factorize e to the power p times t times e to the power p minus 1 is 6. So here this is maybe a little bit thinking out of the box. I guess you kind of recognize this e to the power p and e to the power p are the same. So you can just say, okay, let's give this a new name q, and then that will be an equation that you will be familiar with. And you get q times 2q minus 1 is equal to 6. And these are like the quadratic equations you worked on for many years. So you get 2q squared minus q minus 6 equal to 0. You can either use the how is it called, the equation with the discriminant or determinant. No, sorry, discriminant. That's always a safe method if you cannot find how to factorize it. But you can just try out if factorization is possible. Okay, start with it has to be 2q squared, right? So you start with a 2q here and a q here, and then fiddle around a little bit with these numbers here, and obviously you will try all kind of factors of 6, right? You try 1 and 6, or actually minus 1 and 6, or 6 and minus 1, and etc. I guess you can also put it in your graphic calculator and then write down this, since then you know the factors. I think that is okay. Anyway, so this is what you find. You get q is minus 3 over 2, or q is 2, but e to the power p cannot be negative, so we just rule out this. So we just have that e to the power p has to be 2, and which just means that p is log of 2. And that is the exam result. Definitely a lot of hard work. I hope it gives you some insight in what is needed. I did the previous exam, and I'm going to do Tijdvak 3 also if possible, and also try to follow up with the 2021 exams.